Hello, everybody. Welcome to episode 3 in the Trivandrum Chapter's monthly fireside chats. Today, I have with me Dr. Rajasree, whom I will introduce in a minute. But before that, let me just give you an idea of the process we're going to follow. And in the meantime, I'll also add a few people to join the call. The process is that we will first have um, a 5 minute opportunity for Professor Rajasree to give us an opening remark. And then after that, we will have, let's see, hello, are we there? Did I lose you guys?
No, we can hear you, Raju.
Okay,
Go ahead.
okay.
Yeah.
I can't see myself, so let me just go find out what's okay. Let's see. All right, I have it. Right. So 5 minutes for Professor Rajasree to give us a brief overview. And then after that, we will open it up for my questions. I've written down 3 or 4 questions. So that'll take maybe about 20 minutes. And at the end of that, we'll leave about 10 minutes for questions from participants. Now, I have to bring in the participants. They're all waiting in the waiting room. So let me bring them in one by one. Okay, here they are. I've admitted them. All right. Okay, so for all the people who are participating, you can go to the little button at the bottom that says chat, and that'll bring up a chat window where you can ask questions. What we'll do is at the end of the program, the last 10 minutes, we will devote to your questions. Okay, so please enter your questions. I'll pick them up and then ask them towards the end of the program. So without further ado, let me now introduce Professor Rajasree, who is currently the CEO of TrEST Park, which is Trivandrum Electronics and Science
Engineering Science.
Engineering Science Park. I lost my window where I had your comments, so I'll have to bring that up. And before this, she was. Well, let me ask you to just introduce yourself. You know yourself better than I do. Go ahead, madam.
Okay. Good evening, distinguished members of IIT Madras Alumni Association, Trivandrum Chapter, and the entire IITMAA. I'm very happy to be speaking with you as an alumni of IIT Madras. I was in IIT Madras in 2 spells, 95 to 1995 to 1997 for my MTech program, and 2001 to 2004 for my PhD program in the Computer Science and Engineering department. So I was working with Professor Kalyan Krishnan for my MTech and Professor D. Janaki Ram of Computer Science department for my PhD program. So I completed my PhD program in 2006. I was working in the engineering colleges of the state in various capacities, assistant professor, professor, principal. Then I also had an opportunity to work with IITMK, which is Indian Institute of Information Technology Management, Kerala, which was later transformed into the Digital University of the state in 2018. Then I was also the Vice Chancellor of APJ Abdul Kalam Technological University, the first technological university of the state, which governs all the engineering colleges of the state during 2019 to 2022 October. And I retired from my service in State Department as Director of Technical Education. Now I am associated with TrEST Research Park, Trivandrum Engineering, Science and Technology Research Park, which is a Section 8 company under the government higher education department, which is modeled along the same lines as the IIT Madras Research Park. So this is one reason why I would like to be associated with you when I'm trying to building something which is very unique and which is very critical at this juncture where we are refocusing our engineering education from the conventional way to innovation to become self-reliant and more deep into the technology. So today's talk, Professor Rajiv, you will be introducing the
the
topic of
topic.
the session today.
Yes, ma'am. Yeah, the topic that we discussed is opportunities for an electronics and semiconductor ecosystem in India and to some extent in the various states. And the question that really we would like to touch upon, maybe not answer fully, is if you look around, you see these two behemoths. You see the United States and China as dominating electronics and in particular semiconductors now. What can India do? Where are we? We've talked a lot about it in various contexts, but what is happening on the ground? So, what I'm hoping that you'll be able to do, madam, is to bring to this audience some information about various aspects of the semiconductor program. So, let me just ask you one or two questions and to kick this off. One is there is the India Semiconductor Vision or Mission, right? So there are a number of initiatives that are going on under the scheme by the private sector as well. So what has been actually created on the ground? And can you talk a little bit about some of the projects that are under this India Semiconductor Mission? And importantly, can you also talk about when some of the results will be available? Because we want to see that the stuff coming out of India very soon as well. So if you could just touch upon the India Semiconductor Mission and when we can expect some output from that, that'd be great, madam.
So the overall mission is to make India a self-reliant ecosystem for semiconductor design and manufacturing. So this is multiple components involved. One is establishment of a robust ecosystem to support the entire value chain from design, fabrication to assembly, testing, marking, and packaging, and then promoting indigenous innovation and design. Schemes such as Design Linked Initiative have been introduced for this. This provides financial and infrastructure support to startups and companies working on chip design. The goal is to move beyond simply assembling devices to become a leader in designing and building chips in India for the world. And along with this, fostering research and development and skill development has been a key thing, which is this forms a crucial part of the mission. This is important because we need to have a long-term growth to become for India to become a knowledge-driven hub in semiconductor design. Then attracting global investment and partnership is very important in this because India can't do everything from scratch. So the mission is also trying to do that both from domestic market and also from foreign companies by building strategic partnership with global players to integrate India into the critical global supply chains. This is to ensure a reliable source of secure and reliable source of semiconductors. Then we need also to have technological self-reliance, especially when India is talking about Atmanirbharata and all. We need to reduce the dependency of imported semiconductors and also the components which are used for manufacturing semiconductor devices. So the domestic capabilities has to improve. The country aims to achieve technological sovereignty and more resilient economy, particularly for strategic sectors such as defense and telecommunications.
Yeah, you touched upon the supply chain, madam, if I may interrupt. Yeah. We need to have a supply chain in India that's pretty much independent of China and maybe others. And I believe there is the electronics component manufacturing scheme that's planning to bring an entire indigenous supply chain. Can you say a little bit about that?
Yeah, that scheme is also in alignment with the scheme for promotion of manufacturing of electronic components and semiconductor specs. It is called, and it is a key component in the component manufacturing push. And this follows the electronics manufacturing clusters, which was a success previously. So this is to strengthen the domestic supply chain and reduce dependence on imports from countries such as China. So the the strategy is to provide 20% of capex to companies as financial incentive for such component manufacturing infrastructure building projects.
That's like the PLI, isn't it? Somewhat like the PLI? Yeah.
Yeah.
Okay. So you actually are incentivizing entities to do capex by offering an incentive of 25%. Okay. Now, to broaden the perspective a little bit, see, we've heard a lot about the problems that Indian IT companies are facing in the wake of, the H-1B fees and also losses to generative AI type mechanisms, job losses to that. So, do you think that it's possible that semiconductors and electronics can really come to the rescue of the Indian IT, to define it broadly, including electronics? Will that happen? Is that a likelihood here?
Yeah, that's a very valid question in this discussion because it is very likely that this increase in H-1B visa fees is going to have a counterbalance because many IT companies, especially service companies, outsource our talent to US and other countries. So this is going to become a major overhead for them, for their resources. So it is very likely that they will have alternate strategies for addressing this issue, for mitigating this issue, like having use of generative AI or something like that. And this gives us an opportunity to convert our specialized IT talent into semiconductor design. Though I said it so, it's not something that we can achieve very easily because in semiconductor chip design and all, the talent is not as easy to be built as IT talent, where you learn some tools and then become competent to build systems for the enterprise and all. So that is where the critical difficulty is coming in, where we have to have very deep subject knowledge and also the laboratories for doing this. Then the EDA tools, electronic design and automation tools, which are very costly, where the design incentive becomes very useful for these capacity building initiatives. So it is very much possible for us to have the job losses due to generative AI be balanced by aligning our IT workforce to semiconductor related jobs such as fab, ATMT, and design jobs.
Well, you mentioned design. Now, if I'm not mistaken, something like 20% of the world's semiconductor designers are in India. Now, as you said, turning that into manufacturing and fabs may be pretty hard. So, should India continue to focus on just fabless designs? That is to say, we do the design here and outsource the manufacturing to, I don't know, TSMC in Taiwan or something like that. Does that make sense?
Yeah, that makes perfect sense because that will be the first opportunity for India to take that, make the designs here and then manufacture elsewhere till our manufacturing facility gets ready. So that will be the best option for us.
Okay.
So we have got, as you said, 20% of the design talent in major companies like the Qualcomm and all are here from India. So that is a great opportunity for us and further develop the Indian talent towards this.
Right. Well, given all this, do you think India can be one of the primary sources of semiconductors? I mean, maybe in a limited geography, like the Indian Ocean area or something, by, I don't know, in 10 years. Do you think India can be one of the major providers of semiconductors?
Yeah, it is possible because in India can be a trusted companion for these countries to become a supplier of semiconductor chips. but the mature ones, not the very sophisticated 2-3 nanometer things, but which are proven nodes. It is very much possible for India to become one like that.
Yeah, I read somewhere that China already has like a $2 trillion semiconductor industry, whereas India is only expected to reach maybe 120 billion in 5 years, 2030. So we have a lot of room to grow, right? Because it's really a big market out there. But the other issue is that as you pointed out, there are different grades. Like everybody's talking about the 2 nanometer, 5 nanometer, very advanced chips. India is not looking at that at the moment, correct? We're looking at things that are 28 nanometer and onwards. Is there a substantial market for these, what one might call older generation semiconductors still, or is it kind of diminishing, and that we should be looking more
Yeah,
at the
it is definitely there. It is definitely there for 28 nanometer, 40 nanometer, 55 nanometer, 19 nanometer, and all. These chips are very essential for applications such as electric vehicles, consumer electronics, power management ICs, display drivers, and all. So
yeah.
this demand is not going to diminish, and this demand is going to be plenty. So as long
Okay.
as this is there, India can be a constant supplier of these kind of chips.
Okay. From what I have read, the Tata Group seems to be the biggest private sector investor in India. Would you be able to comment on that? What are they doing, and what kind of money are they spending, and what will happen? When will something come out of them? And who are their partners? Any thoughts on that?
Yeah, we have three major three major projects that are coming in India as part of India Semiconductor Mission. The first one is going to be these three. Two of them are in Gujarat and one is in Assam. So Tata is in different ways. Tata is participating in these projects, and also in Karnataka. Karnataka also there is a project coming up, which is again as part of DLI. Then Tata is investing majorly into these projects. Tata Motors and electric vehicles, that they are investing. They're also concentrating on that is for their internal demand, for their captive market, which is so that will be a kind of de-risking them from their initial massive investment for if they use it for vertical integration. So that is happening to a great extent.
Okay. So what about real hardcore design? Are they doing anything in apart from everything else, creating intellectual property? Because I thought most of the design talent in India or Indians abroad are all working for foreign companies. Is Tata spending some effort on that as well? Creating
Yeah,
new.
that is also there. Tata Electronics provides design services, and
Yeah.
and it aims to co-create a local IP ecosystem. They already have an MOU with CDAC for the Center for Development of Advanced Computing, which is a government agency. Their facility is their fab is being used for ASAT capabilities to support Indian startups, academia, and MSMEs for designing their own chips. So this provides a domestic pipeline for chip design from concept to physical chip manufacturing through that SCL, Semiconductor Complex Limited. It is being fabricated. That's happening in the academic and research and development institutions.
So when will some of this actually materialize? Indian chips, when will they start showing up in the market?
Yeah, the first level of chips the packaging and all will happen by the end of 2025. That is what I understand from the resources that are available. Then the complete manufacturing from end to end, from the silicon wafers to the chips, it is going to take another year, 2026, end of 2026, it will be ready. That is what the semiconductor mission says.
Okay, so something is going to happen this year. It's not fully indigenous, but there is, there is some level of, and this must be 28 nanometer chips. Is that true, or even older technology?
These are going to be 28 nanometer chips.
Okay, so mature nodes.
Mature nodes. Yeah.
Right. And then what you're talking about, the wholly indigenous part, will that be again same level of nodes, 28 nanometer or thereabouts, or are they more advanced?
No, that will take time because this is a proven technology. Only that will be possible for us. It is not. We can't imagine India competing with Taiwan for 2 or 3 nanometer chip. But I believe the strategy will have to be like provide 80% chips for the world in a resilient way, using proven technology and then nodes which are proven.
Right. Okay. For those who are listening, please go ahead and ask any specific questions because I've got about, I think, a few minutes left where we can answer questions. So let me ask a couple of questions that have come up, madam. Oops. Let's see. Where did that question go? This is from somebody on an iPhone. It says, I have a question about IP. Can our speakers elaborate about the challenges faced? So intellectual property, madam, would you like to respond to that? The creation of intellectual property in this area. So I guess design itself is creating IP, isn't it?
The design itself is creating IP, and some of the IPs will be available for other designers also, which they can use. Then we have one company in our TrEST Research Park, Netra Semi. Their chip is, this is an edge EUI chip. So the chip is a bundle of their own IPs. So they work on the...
Can you talk a little bit about that DLI program? Because everybody's heard of the PLI. You just mentioned Netra, or is it Netra? One of the two, right? So they have a design-linked incentive program. They're a winner in that. Can you elaborate on that a little bit?
So this will be like providing the EDA tools from major tool vendors like Cadence, Synopsys, etc., free of cost to the startups who are in the design of chips. Semiconductor chips. That's what this is about. And also academia is promoted to be part of this project. They can submit projects to MIT in association with the company which is into semiconductor chip design. And then our College of Engineering Trivandrum is a recipient of this project. Is called Chip to Startup, which has been of immense help to for academia to get into chip design, because for institutions the budget and all will not be sufficient for subscribing these EDA tools, which are for various purposes. These tools are there. The entire design can be fabless, and only the final fabrication of the chips can go to foundries. The rest of the things can be done completely in-house. The entire life cycle of design and development.
That's a lot of intellectual property, right? There's a lot of IP that they create. Okay. Now, Vijay Kumar asked a specific question. Which software tools do you suggest for fabless design or for OSAT? Any thoughts on that?
So many of the tools are from Synopsys. They have, I will not be able to name the software tool. Cadence, Synopsys, and these companies provide very specific tools for all these applications. They are collectively called EDA tools, and CDAC facilitates access to these tools for academia and also for startups. Startups can directly apply to MIT for access to these tools. These will be provided free of cost to startups. That's what's happening. And this Netra Semi was the beneficiary of all these schemes supported
Okay.
by the government. And more than that, we also need testing facilities, instrumentation labs with electronic equipments, costly or oscilloscopes and things like that. Those also should be made available for these kind of startups to easily work on. In their early stages, they will not be able to get all these equipments on their own, electronic equipments. So this facility, along with these tools, will be a great value add for interesting students and startups to work on this. And there are many problems.
Yeah. In that context, so please continue. I thought you had finished. Please continue.
Yeah, the company I mentioned about, this Netra Semi, they are working on edge intelligence, I said, which means a camera will have an intelligent chip. So the processing can also happen in that chip without it going to the network and consuming bandwidth and all that. So everything happens very quickly, intelligence at the edge devices. So this concept is very popular for any number of devices which we can think of in ubiquitous computing, sensors, and all those things. So such a chip itself opens up several problem statements for several other domains where startups can pitch in and then they can work on this. So this is a very interesting industrial opportunity that is coming in India because of this trust and democratized access to the tools and facilities. So
in that context, here is a question, Madam. Here's a question on that. Gopakumar asks this question: what are the job and internship opportunities available at present at TrEST? Are these EDA tools accessible for technical people on request? How can people get access to them? Is what he's asking.
Yeah, this is possible because having realized the importance of a common ecosystem for enabling these kind of deep tech startups, that's how I would like to call them. What we have done is, in specific colleges, we have opened satellite centers of TrEST. So what they can do is they can request us to get access to these tools. Every academic institution has academic license of these tools that is already there. But in addition to that, if they want, but that will be limited. Some of the facilities and some of the capabilities will not be available for the with this. But these students can come to TrEST Park and access this tools.
Okay. And
then there are also some other,
go ahead.
So the TrEST Research Park is also planning to expand this segment on semiconductor design by having a semicon lab opened for the state to have capacity building programs and also student and faculty development programs. Because one of the main aspect of ISM, India Semiconductor Mission, is to have a large number of talented students, to have a talent pipeline for these kind of jobs in the country, which can happen only by engaging with academia, by having proper curriculum alignment. How can the mechanical engineering students open up to design EV chips, or electrical and electronic students look at EV chips? So it is like for specific applications, how can they, from idea to chips, how can they work from an idea to a chip? So that life cycle of a chip, that is very important. And wherever we can do, what are the infrastructure, the mentoring requirements, all this is part of this program that TrEST Park is conceiving now. It's in early stages. We haven't materialized it, but it will happen soon.
The next question, this is from Debjyoti Bishwas. He says, I'm a faculty at a private university and my PhD is in semiconductor fabs. I want to establish a startup in the area of semiconductors. As a very small startup founder without huge backing, what area would you suggest? So maybe he should talk to you offline, because we can provide your contact.
I can share my email address and my number. You can talk to me.
Yeah,
If
can
you are
you just
interested, you can come and set up a company in TrEST Park itself.
TrEST Park. Can you just share your email ID right now, madam? Just
CEO at trestpark.org. Should I?
TrEST Park, right?
Yeah.
TrEST Park dot. Okay.
Yeah, I've put it. CEO at trestpark.org.
ORG. Okay. CEO at TrEST
Yeah, are you able
PARK.
to see it? It's in the chat
I can't.
box. Yeah.
Yeah. Okay. I haven't seen that. Okay. We'll see it there.
Yeah.
TrestPark.org. Okay.
Yeah.
Next question from Vijay Kumar. It's there. Okay. From Vijay Kumar, which area should India focus on? ICs like controllers, memory or power semiconductors like IGBT or MOSFET? Do you have any response to that from Vijay Kumar, madam?
It is, see, in the facility that we are establishing now, they are focusing more on the power chips.
Okay. Next question from Mr. Karmachandran. Why was India a late entry into the development of semiconductors?
Yeah.
Tough
Maybe
question.
after IT services, and we we never thought that this is not going to be a resilient economic booster for India. So we have been after.
Yeah, I remember how Intel wanted to set up a fab in India and we just sat on it. So they moved to Malaysia. So I think it's just been, bad strategy on the part of the government. Okay, next question from Ramesh Waswani. What sectors of local manufacturing will be catered to by our chip producers and how much forex will we save? So I think the answer is it's pretty broad, right?
Yeah,
I think defense,
it is pretty broad.
definitely.
Yeah.
Right.
Yes, we can have healthcare, medical instruments, because it is not only it's a lot of computing at the edge. That's what we are looking for. If there is a doctor using a device and then there is a database somewhere, then going computing or computing something and giving the results.
Yeah.
But it's not like that. Intelligence at the edge and computing at the edge is going to make a very, very fundamental difference. Then in EV, then space vehicles, any number of applications that you can think of. Once we used to think like hardware, which is general purpose, and software, special purpose on that. Now we can have a way of thinking it the other way. We have everything in silicon.
Okay. I have 2 minutes left on the clock. So let me ask a question from Dr. Subramanian. Given various constraints such as design, capital intensive, supply logistics, import of wafer, lack of infrastructure, bureaucratic delays, what is your comment on the strengths, weaknesses, and threats and opportunities here? That's a large question, isn't it?
Yeah.
So,
If we look at the mission from 2021 to 2025, the way it has grown, the way the mission was implemented, it is addressing all the threats that can be there in such a huge, in realizing such a huge vision. So it is not that, and also the right strategy to put it. It's not competing with what a country like Taiwan, which has been into this for several decades doing, but have something which India can afford to start with. And then at the research and development level, there are projects in major institutions of national eminence, which is looking at chips at very nano scale and all. That is how the whole scheme is positioned. So,
okay, madam, I think we're just about out of time.
Yeah.
I'm sorry. I just wanted to make a comment here that came from Rohan. He says, I'd like to bring your attention to our inaugural sports meet happening at the end of October. IITMAA is sponsoring that. So with that, I think we're pretty much totally out of time. And I would like to thank you and all the participants for being here. Rohan says there's a variety of games in sports such as bridge, chess, etc. So we'll leave it at that. Again, your Thank you for your time, madam. And your email ID is CEO@TrEST Park, TrESTPARK.org. So anybody who wants to reach out to her is well.